In this question, he is asking the number of points where the function fx defined by this, where box T denotes the greatest integer less than or equal to T, is discontinuous, is you have to fill in the blank. Obviously, the interior portion is a polynomial, and polynomial function is always continuous function, and we also know that modulus of continuous function is also continuous, hence this whole is always continuous function. Similarly, x plus 1 is continuous, hence mod of x plus 1 is continuous. X minus 2 is continuous, hence mod of x minus 2 is continuous. And continuous plus continuous is also continuous. Hence for x less than minus 1 and for x greater than 1, the function is sure to be continuous. The chances of discontinuity are at minus 1, 1, and those points where the interior part is an integer. Note that minus 1 can go outside because integer can go outside. Also note that box x square is discontinuous at all the points wherever x square is an integer, but at x equal to 0, y equal to x square has local minima, hence at x equal to 0 it is a continuous function. You have to take care of it. At all other values, wherever x square is an integer, this will be a discontinuous function. And now first of all, let us discuss the continuity at minus 1. Limit x tends to minus 1 minus fx. When x is tending to minus 1, this whole will be tending to 2, and value of f minus 1 is also 2. Also note that an integer can go outside, hence our calculation will be slightly more simple if I write this as box 4x square minus 1. That is, instead of this, I'm going to write this. Looking at it, I can easily say that limit x tends to minus 1 plus box 4x square minus 1 means x square will be slightly less than 1. Take care, when x is slightly more than minus 1, the value of x square will be slightly less than 1. Hence the value of this whole will be slightly less than 4. Therefore the value of this will become 3. 3 minus 1, 2. Hence the function is continuous at minus 1. And next point to be checked is x equal to 1. Clearly, limit x tends to 1 minus box 4x square minus 1 will be equal to, now x is slightly less than 1, therefore the value of this will be slightly again less than 1. The value of this will be slightly less than 4. Therefore the value of this will become 3. 3 minus 1, 2. And it is also clear from here, right hand limit and value of function will be 3. Therefore the function is discontinuous at x equal to 1. And now remaining points to be checked are when x lies between minus 1 and 1. When x lies between minus 1 and 1, it is clearly a even function. Therefore, we'll be discussing the continuity only in 0 to 1. At 0, I have already told you it is continuous. If in 0 to 1 it is discontinuous at n points, then in -1 to 1 it will become discontinuous at 2n number of points. Now, if x lies between 0 and 1, x square will also lie between 0 and 1, and which means 0 is less than 4, x square less than 4. Therefore, the possible integral values which 4x square can take are 1, 2 and 3. That is when x is under root 1 by 4, under root 2 by 4 and under root 3 by 4. Hence, in the interval 0 to 1, it is discontinuous at 3 points. Therefore, in the interval -1 to 0 also there will be 3 points of discontinuity. And one point we have already found, that was 1. Hence, I can say there are 7 points of discontinuity.